Hey, this is chapter 9.2, and we're going to be covering the first of our conic sections, which is the parabola. Now, later in section 6, the book will actually define what a conic section is, but I think it's helpful to know what that is now. So they say that because parabolas, circles, ellipses, and hyperbolas are formed when a plane intersects a double-napped cone, they're called conic sections or conics. So if you're curious, it's just you have a cone. Oh, that's bad. If you have a cone on top and a cone on bottom, you could get our parabola from here. You get our circle from here. You have our hyperbola here, etc. So that's just basically where the word conic section or conic comes from. So the basic equation of a parabola, as we know, is that of a quadratic function, which is y equals ax squared. So we're going to be identifying certain parts of the parabola, namely the vertex, which we know is, in this case, 0, 0, but also the focus, which is on the axis of symmetry, and therefore creates equidistant points. So this point is equidistant from the axis of symmetry as this point, say. And our directrix is a line which is perpendicular to the axis of symmetry. Each point is also equidistant from the directrix. So we will be told to graph x equals negative 1/8 y squared. And so you're probably noticing that this isn't in the same form as our previous equation, and so therefore we need to transform it so it looks like that. So we have negative 8x equals y squared, or y squared equals negative 8x, and now this looks like our y squared equals, our y equals ax squared. Yet there is still a vital difference, which is what I just kind of mentioned in my mistake, which is that instead of the x being squared in this example, the y is squared. And this will, in reality, flip or shift our parabola, as you will see. So the book tells us next to identify the focus, directrix, and axis of symmetry. Now our equation has the form of y squared equals 4px. So if we're thinking in terms of this equation, we have y squared equals 4 times negative 2x, in which p is negative 2. Therefore, the focus is p0 or negative 2, 0. Next, the directrix is x equals negative p, or x equals 2 as our directrix. And because y is squared, the axis of symmetry will now be the x-axis. So based on that, you can kind of visualize what this graph will look like. It's going to be facing the left with an axis of symmetry as its x-axis. Its directrix will be here, and we have a point at negative 2, 0, which is our focus. So this is our graph, and we can draw in where our directrix is because they don't have that. So that will be at x equals 2. And then our focus is negative 2, 0. And this we label as our directrix. Our axis of symmetry is the x-axis. And there we go. We have x equals negative 1/8 y squared. This was our original formula. So So now we're kind of going to be doing the opposite. Instead of drawing a parabola based on a given equation, we're going to be writing an equation of a given parabola. So the graph shows that our vertex is at 0, 0, and our directrix is y equals negative p. So therefore, y equals, I'll write that down, y equals negative p, which is negative 3 over 2. We will substitute 3 over 2 for p in the standard form of the equation of a parabola, according to our textbook. So we're going to have x squared equals 4py, and for this p here we will substitute 3 over 2. And then we're going to simplify, and we get x squared equals 6y.